Oops, I missed something, didn't I? I missed the opening thing again. So let me get this. Whoop. All right. So the sum of the first n terms of a geometric sequence is given by that thing. So I think how that is supposed to look is like this. S sub n is equal to the sigma notation, whoop, 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 from r equals 1 to n of 2/3 times 7/8 to the r power. Find the first term of the sequence. Okay, well, to find the first term of the sequence, I'm finding u sub 1. Now it says it's geometric, right? And so let me get our formulas for us right here. I have them ready to roll. Back up here, boom. Okay, so for the nth term of a geometric sequence, it's right here. Okay, so that's u sub n equals u sub 1 r to the n minus 1, right? So u sub 1 is equal to 2/3 times 7/8 to the 1 minus 1, or 0. And remember, anything to the 0 power is 1. So that's 2/3 times 1, which is 2/3. So hopefully, after I show you this, you'll never have to plug everything in again, but no big deal if you do. The first term of any geometric sequence, when it's in a sigma notation, is always the coefficient of the term with the exponent. It's always going to be that, because you're always going to get the 0 power from the formula. Okay, so you can just write that down if you'd like. Okay. Also, remember, the common ratio is always the term that is being raised to the power. Always. That is the common ratio. So, okay, let me make that a bit smaller. Maybe we'll have enough room to keep it all on here if I can get rid of this. Okay, so B, find the sum to infinity. Well, all right, fine. Sum to infinity, right? And the sum to infinity formula for a geometric sequence is right here. Note, Bernardo, I have grouped all of these together, but this formula is further down on in the formula booklet, which makes me crazy. They group it with something that makes sense, but I think it makes more sense with this. Doesn't matter. But just remember, this formula is further down on your formula in your formula booklet, on that same page. Okay, so that formula is u sub 1 over 1 minus r, which would be 2/3 over 1 minus the common ratio, which is 7/8. Okay, so that is going to equal 2/3 over 8/8 minus 7/8, which is 2/3 over 7, or 1/8, right? Keep change flip, so that becomes 2/3 times 8/1, because you're dividing by 1/8, which means you multiply by 8/1. So it becomes 16/3. That's the sum to infinity. All right, boom. Oops, oops, oops. A little smaller. Okay, so what the heck are they asking about C? Find the least value of n such that s sub infinity minus s sub n is less than 0.01. Holy smokes. All right. Well, we already found that the sum to infinity is 16/3, right? Minus the sum of n terms. So we got to find how many terms this is true. Okay. Well, the sum of a geometric sequence is this guy, right? Or this guy. You can use either one. I always use the first one. So we're going to put that in there. U sub 1, r to the n minus 1 over r minus 1. And we need that to be less than 0.001. So in order to solve this type of equation or answer the question, you have to set it equal and then interpret the answer. I'll show you what I mean in just a sec. All right, so let's plug in what we got, 16 over 3. The first term is 2/3, u sub 1. The common ratio is 7 over 8. Oops, 7 over 8, and that's to the n power. And remember, that's what we're solving for, minus 1 over the common ratio, which is 7/8, again, minus 1. And we want to know when that is equal to 0.01. We're going to graph this bad boy to solve it in just a second, but let's clean it up just a little bit, I think. I mean, you could put it in like this if you wanted. You could. But it's a little nasty. I don't know. That's a lot to enter. So, I don't know. I think I'm going to clean this up a bit. 16 over 3. Now, 7 over 8 minus 1. Just a little scrap work. 7, 8 minus 1 is 7 over 8. Minus 8 over 8. That's equal to negative 1 over 8. So 16/3 minus 2/3. Oh my God. 2/3 times 7 over 8 to the n power minus 1 over negative 1/8 equals 0.001. Here we go. And again, I'm cleaning it up to just so we don't have such horrific things to enter. Again, you could enter this thing if you wanted to graph it. 16/3. Now when I divide by a fraction, I multiply by the reciprocal. Also, I've got a negative over a negative, so it makes it positive. So I'm just going to take 2/3, or 8 over 1 times 2/3, or 2/3, scrap work again, times 8 over 1. Because if I multiply by the reciprocal, that's just going to go out in front there. You can put it in back, but I can multiply it by this fraction. So this would be 16 over 3, right? And now I don't have this fraction anymore because I multiplied by the reciprocal. So this would be 16/3 times 7 over 8 to the n power minus 1. And I think, just to make my life easier, I'm going to subtract the 0.001 and set it equal to 0, because that will be easier to find the answer, I believe. So let's go ahead and graph this function right here. Here we go. So I need to add a graph, control plus page. I'm going to add a graph. Oops, I forgot. I think I have to do this thing again. That makes me crazy. Okay, I added the graph. Great. Okay, so remember, 16/3 plus this guy. So I'm going to do, and I recommend you do this with the fraction bar so you know you're entering it in correctly. Okay, plus all of this, plus fraction bar, 16 over 3 times, got a parenthesis, and I got another parenthesis with the 7/8, fraction bar, 7 over 8 to the x, so I have to hit my caret. There's my variable. Can't use n, got to use x. Make sure you arrow over -1 outside the parentheses minus 0.001. Woo! And then see this, the reason this is so nice and you use the fraction bars, you can make sure it's exactly what you wrote, Bernardo. Okay, so now I'm going to hit enter and hope for the best. Okay, well, I can see that it's going way to the right, and I got to see where that's equal to 0. So I'm going to do menu. You probably expand. I like to do Windows Zoom and just do my own settings. And I got to expand the X. So I'm going to go out to 100 and see what happens. And then I can see that somewhere in here, it intersects the x-axis. So menu, hopefully analyze graph, find the 0, and there it is. Look at that, 64.3. Okay, so we got to interpret that. Okay, so n is equal to 64.3. Now that's what this value is, but we know a term number can't be a decimal, so we have to interpret this, right? So when n equals 64.3, these guys are equal, right? That means that, where's the question? That s to infinity minus s sub n is equal to 0.001, right? Now they want it to be less than that, right? So n is either the 64th term or the 65th term, right? But since it's equal at 64.3, these guys are equal, then if I went to term 65, it would be greater, but I need it to be less than. So that means it would have to be the 64th term. Woo! Another big one. All right, we're going to make that a video, and we'll go on to number